Hello, welcome back to Algebra. In this lesson, we're going to learn how to graph inequalities when we have two variables in the inequality. Now, you should be very familiar by now with how to graph equations with two variables, meaning x and y. So y equals mx plus b. We've done that many, many times. We're just going to expand a little bit and talk about how do we graph an inequality that has two variables. So when there's an inequality symbol and an x and a y variable, how do we graph them? Now we've already graphed inequalities on the number line when we only had one variable like x or y or whatever. Now we're going to talk about inequalities that have two variables. The good news is it's going to be very, very, very similar to everything we've already learned about graphing lines. So that's why we cover that first. Now we're going to graph the inequalities. So the easiest way to do it is to jump into an example. What if I give you this inequality? Y minus 2 is greater than or equal to 0. Now I know I told you that there would be two variables right now, and this is actually a special case, so you don't see any x's anywhere. But for now, just kind of go with me through a couple of examples and you'll see the parallels that we're going to draw between graphing lines and graphing inequalities in two variables. The first thing you do is that when you have an inequality like this, and you have the arrow, and here we have a greater than and an equal to sign. What you want to do is move everything over to the right-hand side, just as if it were a line. In other words, the very first step in graphing any of these things is just to pretend that what you have is actually a line and not an equality. So if this were not a greater than equal to, if this just said y minus 2 equals 0 and you wanted to graph it, well then what you would do is you'd move the 2 over there and then you would graph it, right? So let's go ahead and do that now. We move the 2 over just as we always have the ability to do by adding 2 to both sides. So if we add 2 to the left, it's going to disappear. And then on the right-hand side, it would be 0 plus 2, so we'll have y greater than or equal to 2. So these two inequalities are exactly the same thing. This one just has the 2 moved to the right-hand side of the inequality. Now, in order to figure out what this is really telling you to graph it, what you have to do is, first of all, just pretend it's a line. What would you do if the line were not y greater than or equal to 2? What if it were something like y equals 2? So first of all, you just pretend it's a line. And if you remember that this is a special kind of line from the previous lessons we've talked about. This is a horizontal line. When you have a line of y equals 2 or y equals 6 or y equals -5, y equals a number, it's just a horizontal line at that point, because what it's telling you is that no matter what value of x you have, x isn't even in this equation, so it doesn't matter what x is, the y value is always 2. So if you were going to graph this line, y is equal to 2, what you would do is go over here to the board here, and we have here's 0, here's 1, here's 2. You would put a little dot right there at y is equal to 2, and what this line is telling you is that all horizontal points going through y equals 2 is what we're going to basically have here. So there we go, like something like this. So we have double-headed arrow like this. Unfortunately, what we've done here is we've just graphed the line y is equal to 2. But you see, this is not what the inequality that you're actually trying to graph is. It's telling you that y is greater than or equal to 2. So what this is telling you is, forget about the greater than sign. The line below means that y values can be equal to 2, but this is telling you that y can also be greater than 2 at any place. So what it's basically telling you is that the y value of all of the points described by that inequality is not just on the line y is equal to 2, it's all of the points above that line. So basically it's all of these, you shade everything is what you end up doing. Every point above the line, y is equal to 2, is part of the solution of this inequality. So you see what we've done, and these should come on down. Now don't forget, this line is a double arrow, so it goes on in both directions forever and ever. What you have figured out is that the inequality y greater than or equal to 2 is every single point, everywhere above this line, all over the place, up to positive infinity, over to left and right, but none of the points down here. Now how do you know that that's the proper graph for this guy? How do you know? Because it's just telling you that the set of points where y is greater than or equal to 2 is a solution. So if we pick a point up here in the shaded region, the y value, let's say right here at 5, the y value is 5, that's greater than 2. The y value here is 10, that's greater than 2. What if we go over here? Well, the y value of this point notice right here is 10, is also 10. The y value here is 5. The y value here is 7, and so on. So those are all greater than 2, because all it's telling you is that y has to be greater than or equal to 2. So what you do is you pretend it's a line, you draw the line, and then you say, well, all points for y have to be bigger than that. So we shade all the y values up above that line. Now, one important thing you need to keep in mind is that because this was greater than or equal to 2, we put a solid line for the line down here, because it also includes the points on this line. And in the next problem, what we'll have is we'll take away and we'll make it greater than without an equal to. And if you have that, you'll put a dash line, because in that case, you're not including the points that's actually on the line. All right, so let me go and erase this and we'll do the next one. All right, welcome back. The next problem is going to look like this type of inequality. X plus 1 is less than 0. What if we want to graph this inequality? Now, you kind of need to know that it's really an inequality in a two-dimensional xy plane, but so if this were a line, if it was x plus 1 equals something, what would you do? You would just move the number over to the other side. So we'll subtract 1, and so you'll have x on the left, and you'll subtract 1, giving 0. Subtract over here, you'll get a -1. So there you have an inequality. X is less than -1. All values, in other words, we're trying to graph all the set of points in the xy plane where the x value of those points are all less than, but not equal to, -1. So the very first step is that you just pretend this is a line. So in another color over here, the corresponding line would be x is equal to -1. And you should know how to graph x is equal to -1, because if you remember back, we talked about vertical and horizontal lines. When you have x equals a number, that is a vertical line that goes through what point? -1. So where x is equal to -1. So we go over here, we say this is where x is equal to -1. Now here's where you have to be careful, because this is not less than or equal to, this is just less than, so we're actually not going to include the points that are on this line. So to show the difference here, we're going to just do a dash line. So this is a dash line as best I can draw straight. It's not going to be perfect. That's going to basically go down here like this. We put an up and down arrow, so it goes on and on and on, up and down forever. And then we now have drawn the actual line, and now we go over here and say, now we need to shade all the values where x is less than -1. So if you think of this being lower values of x, and this being bigger values of x, and this being x is equal to -1, all the points where x is less than -1 is going to be all of this region way out here, like this, all the way up to that line, but not actually, past it, essentially. And notice that what we're saying is that for this inequality, x is less than -1, we're saying that all of the points in this shaded region satisfy that. Why? Because if you pick a point out here, the x value right at this point is -10, right? Well, -10 is less than -1, so that's why it's valid. Over here, the x value is less than -1. Up here, the x value is less than -1. Over here, the x value is less than -1. But right on top of this dotted line where x is equal to -1, that is actually not part of the solution, because our original inequality did not say x is less than or equal to -1. It said it had to be less than -1. So the points on this line are not included in the solution, and that's why we dash it. So the bottom line is you pretend it's a line, draw your line. If it has an equal to underneath here, then you do a solid line. If there's no equal to underneath the inequality, you do a dash line. Once you've got the line drawn, then you shade left, right, up, and down, depending on what the inequality is. So let me go ahead and erase this, and we'll do the next one. And with a lot of examples, you'll get the hang of graphing inequalities. Okay, for our next inequality, it'll look like something that you're probably a little more familiar. X is less than y. So the first thing you need to do is realize there's actually two variables here. So we said this is graphing inequalities in two variables. Now in the previous couple of examples, we just had an x and we just had a y. That was because those are just special cases of vertical and horizontal lines. Most of the time, any equation of a line, or most equations of inequalities, are going to have two variables, like this one. So we have an x and we have a y. The very first step is just to pretend that it is a line. So if it is a line, we want to get y on one side and all the x's on the other side. So we're just going to literally flip this thing around so we can read it better. We're going to put a y on the left X is on the right. We're not subtracting or anything. We're literally just flipping it around. And you got to be careful. This opens up this direction. The bigger side goes next to the Y. The smaller side goes toward the X. So there's nothing left to do. There's no numbers to move around. So then you have to ask yourself, what would this look like if it were an actual line? Well, the corresponding line here would be Y is equal to X. That would be the corresponding line. And you know, if the line were this, then the y-intercept b would be equal to 0 because it's mx plus b, where b, the intercept is 0, and the number in front of x is just 1, so the slope is equal to 1, which, as you all know, as you write it as a fraction, is 1 over 1, rise over run. So now you have everything known to draw the corresponding line, but when you draw that line, there is no equal sign under here, so you're not going to draw it as a solid line, you're going to draw it as a dashed line. So what we need to do is go over here and put a y-intercept of 0. So we go and put a dot right here at the origin. The slope is 1, which means rise over run, 1 over 1. So you rise up 1 over 1, put another dot. And then what we're going to do is draw a line through those points. However, it's going to be a dashed line because of what we just said, because there's no equal sign in that inequality. We can try to line it up here. And we don't have to be exact. We're just drawing these general solutions as a kind of a graphical way of representing what they really represent. So we have this guy here, and we'll put a little double-headed arrow there. Of course, it goes on for infinity in both directions. So the dashed line means that the numbers on this line are not actually part of the solution here because there's no equal sign here. So now you have to ask yourself, what do we shade? So we're saying y is greater than whatever we've graphed here. So we're saying we want to shade all of the y values that are bigger than what lies on this line. The way you look at it is, when you have y greater than x, the way you say it is, this is the equation of the line, y is equal to x. We want to shade all values of y bigger, in other words, larger than what lie on that line. So if you think of positive y going up, negative y going down, bigger values of y going up, what you want to do is you want to shade everything above this line that has a larger value of y, because that's what's above here. Now you can shade it however you want. You can go left, right, up, down, whatever. I'm just going to kind of shade it like this, just to indicate that it's everything above here, right? You see your books might go left, right, up, down as far as the shading goes. Doesn't matter. Basically, you just need to shade everything above this guy. So your shaded region here is everything above this line. That means that every point over here that's above this dotted line is part of the solution. Why? Because the corresponding line is y is equal to x, which is right here. But we don't care about what's on that line. We care about all y values bigger than what lie on that line. So if all of the points on this line are given by the dashed line, then every single point above it has a y value larger than what's lying on that line because it's above it. That's why, right? So because we shade above, because we're looking at y values bigger than that. If it were flipped down the other way, we would be shading everything lower than that, y values lower than. We'll do a problem like that here in just a minute. All right, we're cooking along here pretty good. Their next problem is something like this. X is less than or equal to 2y. So again, you just replace this mentally with an equal sign, pretend it's a line, flip it all around so it looks like it's a nice line, and graph that line, and then you do the shading. So the next thing we're going to do is pretend it's a line. So if it's a line, we want to move the y's to one side and the x's to the other. So we're just going to literally flip this thing around, put the 2y on the left, put the x on the right, and we'll have to open this up like this. So we haven't actually added or subtracted anything. I've literally, instead of reading this way, I'm now reading this way. So I've opened it up on next to the y, just like this. But in order to graph it, if it were a line, we'd have to divide by 2 to get y by itself. So divide by 2 here, and then what you'll have is 1/2 x on the right-hand side. All right. So then you ask yourself if you don't have to do this next step now that we've done it a few times, but basically you need to pretend that this is a line. So you say y is equal to 1/2 times x. And if you have y is equal to 1/2 x, then you know that the y-intercept, because it's mx plus b and there's nothing here, so the y-intercept is 0, and the slope is 1/2, which means rise is 1 and run is 2. So then what we go over here is we draw that line, but we notice that our inequality is a greater than or equal to, so we're going to draw it with a solid line. So we go and find the y-intercept of 0 right here, and then we have a slope of rise over run 1/2. So up 1 over 2 put a dot right over there. And now we're going to draw a solid line. We're drawing that solid line instead of a dashed line because of the way everything's defined, because of the fact that our inequality has an equal sign in it underneath the inequality. So then we draw this line. And now we have to talk about shading. So once you have the line drawn, then we go back and look and say, what do we ask to shade? When you have it in this form here, you say, well, okay, this is the corresponding line. Now we're going to go over here and we're going to have to shade all values, all points with a y value bigger than that line. Means with a y value larger than what lies on that line. So basically, you have to shade everything up above because everything up above has a larger y value. And you can shade it however you like. I'm going to go kind of down like this. You can go a different direction, doesn't matter. You just need to indicate that you're basically looking at all points above the line here. Anything below this line, any point down here, is going to have a y value, like the y value here is -5. That's a y value less than what's on that line, and so that's not part of the solution. That's why we're not shading that way. And we'll do another one here in just a second where we are shading less than that line here in just a minute. Let's for now erase and go ahead and do another one to get more practice. All right, for our next problem, we have x plus y is greater than 1. So again, you mentally say, well, I'm going to pretend for a second that this inequality is not here. I'm going to pretend it's just a line. So in that case, I want to get y by itself, so I'm going to have to move x over by subtracting x. So what I'm going to get on the left is just y, because I subtract x, it gives me 0. Then I have over here on the right-hand side, minus x, when I do the subtraction, plus 1. You can think of it as 1 minus x, but then I can flip that around to -x plus 1. So this is the inequality that we really want to graph, that's easiest to graph, and it has a corresponding line, y is equal to -x plus 1. But notice that this one has an inequality without an equal sign under it, so we're going to draw it as a dashed line. So now we have to go over here and graph this line, and you've done this a million times. The y-intercept is 1, and the slope is whatever's in front of x, which is -1, which you can write as -1 over 1, right, as a fraction. So then we're going to go over here and draw this guy. So the y-intercept is 1, so we put a dot right there. And then now our slope is negative, so that means we, instead of rising up, we rise down 1, and then over to the right 1. So it's rise over run, but now it's negative, so we rise down. Down 1 over 1 means we have a dot right here. Now when we draw our line for our inequality, we just need to make sure that we draw it as a dashed line instead of a dotted line, because the points on that line itself are actually not part of the solution to that inequality. So we draw a dashed line through here, right? And then we draw a little double-headed arrow, and then we have to go back and say, how do we shade it? Now we're saying, okay, this is the line here, but I don't care about what's really on the line. I care about shading all values of y bigger than what's on that line. So if this is the value of the points on the line, every point above it is going to have a y value larger or bigger than what's on that line. So you shade everything above it, like this. And when I say above it, you're really going diagonal because it's every point that goes up. And of course, this line goes on forever, so it's really the points over here too, if you extend this line out and so on. But none of the points below the line fall on that solution, and none of the points on the line are part of that solution either, because it's dashed, and that's because we're not looking for the points where y is equal to this, that would be the line. We're looking for the points where y is bigger than what lies on that line. So let's erase, and we'll do one more where we'll have the shading that goes below the line. All right, for our last problem, let's take a look at the following problem. Let's say we have x minus y is greater than 1, which looks very similar to the previous problem. We had x plus y greater than 1 before. Now we have x minus y. So let's see how that changes things. Again, you pretend that this is just a line. So mentally, we're just going to solve for y. So let's go ahead and subtract x, which means we're going to have negative y on the left, negative x plus 1 on the right. We just subtract x here, and it makes negative x. But now we have this negative y, so we need to divide here. So let me go ahead and do it like this. Well, let's do it like this. When we divide by negative 1 on the left, we're just going to have y. But since we're dividing by a negative, remember we have to flip the sign of the inequality. And on the right-hand side, you're going to have negative x plus 1 divided by negative 1, essentially is what you're doing. I'm going to show it very clearly with the steps. So we divide by negative 1, meaning we get rid of it. We flip the sign because we're dividing by negative. We take the right-hand side, we divide by negative 1. Now, of course, on the right-hand side, when you actually do the division, what you're doing is you're dividing the negative x by the negative 1, giving you positive x. You're also dividing this by -1, which gives you -1. So what you've done is you divided the left by negative, giving you a positive. You divided this by a negative, giving you a positive. You divide this by a negative, giving you a negative. So all you've done is you've flipped the signs of every term across every part of the inequality. And when you do that, you have to flip the direction of the inequality sign. Anytime you multiply or divide the inequality by a negative number. We've learned that before. So now what you need to do is pretend that this is a line. The corresponding line would just be x minus 1, which you know has a y-intercept of -1 and a slope of whatever is in front of x here, which is just 1, which you can write as 1 over 1, right? So then we go over here and we say, well, the y-intercept is -1, so we'll put a dot down here. And the rise over run is just 1 over 1. So from that point, we go up 1 over 1, which is this guy, and then we will draw our line, and our original inequality does not have, let me just double check here, does not have a solid line. Yeah, it has an inequality with there's no equal sign underneath here. So because of that, we're just going to go through here and put dash line. Because the point in the dash line indicates, as I've said about 27,000 times, it just means that what's on this line is not actually part of the solution. Something like that, pretty close anyway. So there you go. Then you have to go back and say, well, now what am I trying to graph? So if this is the line, now I'm trying to graph all sets of points with a y value less than the points that are on that line. Not greater than, as we've done in the previous problem, but all y values less than what's that line. So if this is what's on the line, then all points with a y value bigger are up here, and all points with a y value smaller than that are down here. So you need to shade everything down below. You can draw your shading however you want, but all you really need to do is basically say all points down here satisfy that, right? If you extend the line down, then it would be all the shading down here as well. So for instance, this point has a y value less than the point on the line here. This point has a y value less than what's on the line. This point has a y value less than what's on the line. But if you go up here, of course, the point up here is bigger than the y value on the line, so it doesn't satisfy the solution to this inequality. So basically, graphing inequalities is almost exactly like graphing lines. The only two gotchas are the following two things. First thing is, you have to be careful when you draw the line. If there's no line under the inequality, you have to use a dash line. Otherwise, if there is one there, then you have to use that solid line. The second thing is, after you have it drawn, you have to shade either below the line or above the line, depending on what the actual inequality is. And we've done enough examples where hopefully you can see that. Now work these yourself, get some graph paper, make sure you understand it, and then follow me on to the next lesson. We're going to do some more examples to give you more practice with graphing inequalities that have two variables.